this would make it easier for me.
Yeah, hello, my name is Yuri Warszawski. I work at Xebia as well, and I'm Microsoft certified trainer and specialized on the AI. So I will also introduce to you a couple of demos and will help Elena to show you what the AI can nowadays.
Yeah.
Okay.
Maybe you also want to tell us.
Yeah. It's about SkillFest. So our presentation is a part of our SkillFest. So there is now a AI SkillFest going on. So if you want to get more information and get more, learn more about AI, please follow the link that you see on the slide, or just scan the QR code that will lead you to the dedicated page. And after this sessions and after registration, you will be able then get the credit badges, so you get awarded for your learning for your time.
Awesome. I mean, we all like badges, right? I don't do any exams if I don't get to have a badge, so that's just a must-have. Brilliant. Thank you very much for the introduction and introduction of a SkillFest as well. So this is going to be our agenda for today. We're going to have multiple sections. So it's altogether 7 sections, but we're going to have more slides than just this. So we're going to start from what is Agentic AI orchestration, so what it makes, what's the terminology is about, how can we choose a right pattern. So today we're going to have a look at 4 different patterns. There are more to this, but we will focus on only 4 just so we can make it in time. And then we're going to have a look at the governance and production considerations. And of course, there are going to be some key takeaways. So why are we talking about agentic workflows? Why are we talking about orchestration in general? Because we're constantly experiencing shifts in our industry, but right now it's happening from single prompts to coordinated workflows. We are investing a lot of time in instruction files, in skills, and in prompts, but it's becoming not enough, because right now we also want to learn how to coordinate multiple agents and make sure that we get the most out of them, not only one agent, but the whole group of them. So the challenge is no longer only what one model can do, but also how to organize agents so they can work together. And when we are talking about multiple agents, we are also talking about multiple models, so we can leverage all those capabilities and benefits of the of models that fit best for different workloads. So let's have a look at 2 things, 2 parts. So first of all, what makes a system agentic and why orchestration matters. First of all, what makes system agentic? I mean, you can see that there is 4 highlighted items at the screen, which is action, use tools, delegation, and reasoning. So agents take actions. They not only just answer us, give us some information back, but they can also interact with us. Agents can use different tools, call APIs, and read files. And I mean, I think all of us saw those agent files with huge amount of tool sets in there. Agents can delegate to other agents. So that's what we will see as well today. Yuri will be showing us some examples as how one agent can coordinate and collaborate with other agents as well. And they can reason about next steps. So they can have some sort of a conversation, and they can also collaborate until they reach certain agreement. So why orchestration matters? I mean, I think as in real life, we always need to have certain systems, certain processes set up in place. This is the same when it comes to agents. So a single agent, same as a human being, has a limited context and capabilities. So it cannot perform various types of tasks in the same way. So complex tasks need certain specialization, and that's when the specialized agents gonna give us the best output they can. So for real workflows, they always require coordination, which means that someone has to take a lead of the task, has to coordinate who's gonna perform, who's gonna take care of which task, so which specialized agent will be responsible for what part of the workflow. and reliability needs verification and fallback. And of course, when we're talking about verification, we don't mean only agent verifications. We're not only talking about AI, but it also means that a human role in all this workflow. So the verification by human and feedback from the human to the agentic workflow, to the agentic system. So we're gonna have a look, as I already mentioned, we're gonna have a look at 4 core orchestration patterns. We will discuss concurrent, which is parallel execution. We're going to have a look at the sequential execution, which meaning basically the same as the pipeline approach. We will discuss handoffs, and handoffs is based on dynamic routing. And we also going to have a look at the group chat orchestration pattern. I mean, we agreed with Yuri that this one is our favorite because just how interesting it is to observe how all the conversations are happening. So there's like a real conversation happening where different agents are pointing at each other, asking questions. It's quite funny. So I will try to leave as much time as possible for exactly those parts because I think they are the most interesting. At this set, I will start from the first pattern. So I will explain a little bit more in details what does it mean. So what's the pattern is about. And then Yuri will take over. Oh, sorry, I missed a section. So Yuri will take over the whole demo part for all the patterns. But before, I also want to say a couple of words about selection guide in general. So we have those patterns. And I want to highlight once again that the list is not limited to those 4 patterns. There are much more. But when we're talking about concurrent pattern, so it is a very good use case will be when we are talking about independent tasks where speed matters. So we can have a parallel execution of small tasks. We send the same task to multiple agents, and it could be a very good use case when we want to have different use cases for testing, for example, or we need independent task execution from different specialized agents, or maybe even for like comparison or review of different parameters. So this could be a very good use case for concurrent execution. So one of the other examples that you can see on the screen is a multi-source analysis or A/B testing prompts that were already mentioned. When we're talking about sequential pattern, this is when we would be a great fit when we talking about output of one feeds to another agent. So we are dependent on the output from one agent to another. So in this case, agent will be waiting for the response for some input information. Then it will take it in, will process it, and will pass it to a next agent. It's good. A good example for this. It's when we're talking about data enrichment and content pipelines. When we're talking about handoff pattern, is very good for routing, escalation, and specialization. One of the examples, so two of the examples, is a support triage and fallback chains. It's basically we can think of it in a different way as a conditional access. So you can hand off a task to a different agent only if condition is being met. So this is pretty much like an if case scenario. And then we're talking about group chat is we need to use it when we need complex reasoning, no single right owner of the discussion of the process. And it's very good for brainstorming or architecture review. So basically, when you need to get input from multiple specialized agents, and not only from like different opinions from different agents, but also from different perspectives. So it can be, it doesn't necessarily have to be different specialized agents. They can be very similar, but they can give you just different opinions because, for example, they're using different models. That also could be a good case for the group chat. So these are four patterns that we're going to have a look today, and with the examples and use cases where it's best to use them. And we're going to start from the concurrent one. So the concept of concurrent pattern is when we have one task. So we have an orchestrator, first of all. Orchestrator takes care of the delegation process. So it takes this task and then delegates it to multiple other agents in parallel. Execution happens in parallel, which means that it's happening in the, like, much faster than when we have a sequential execution. And then it's the responsibility of orchestrator to combine all those results. So it's very good for independent tasks and comparing approaches, as I already mentioned. And even if you're using the same agent but with different models, that could be. I often get this question, like, how can I test what model can give me better output for certain tasks? Well, that could be a very good fit for this pattern. So you can run one task against the same model, but with the copy of the model, but with different models. And of course, you can do the parallel analysis. And at this point, I would like to ask Yuri to take over the screen and show us an actual example in the code.
Thank you for great introduction. You nailed exactly points of the orchestration patterns, and I will share my screen. So now you see the application that we have currently and which we will try to use. Well, you know, the Copilot, it's a tool, and we will try to do some stuff with the Copilot, but sometimes the Copilot do this change that not really working. So I hope always will be working, but there are some caches. So what we have right now, we have a project about the small financial app. And this app looks like this. So it's pretty simple one. There is nothing about it, but the goal is not the application, but see how those orchestrations, how those patterns working. So we have some application, we have some overview, we have some transactions, so some functionality on the page. And right now, what we're trying to do, we'll try to ask the Copilot to accomplish some tasks. So, and as we already mentioned, we will start with the concurrent task. So for that, first of all, we need a couple of agents that are doing something. And I have a couple of the agents prepared for today's session. So we'll open, and you see there is a couple of them, which will be called in concurrent mode. So first, I will start the implementation, or I will ask the Copilot, and because it's takes some time, I will then represent what the actual agent, what the actual orchestration does. So we have the concurrent, we have the quality assurance orchestrator, and what I will ask the this agent to do is just review the code of the application and enhance the code with unit test and documentation. So let's start this session, and we see the Copilot starts working. And what they're actually going on, we have this orchestration. Let's see what the orchestration is doing. So we have here the description of the orchestration. The role of the orchestration that we're describing, that he is an orchestrator agent that is responsible for coordinating multiple special agents in parallel. And here we're describing what exactly those agents will do. So if we ask this agent to review, enhance, and validate a feature implementation, it should concurrently, so in parallel, launch 3 different agents. The first agent is documentation generator. So we have the documentation generator, an agent that goes through the code and tries to generate documentation to that code. It will analyze features that are implementing, it will analyze APIs, workflows, business rules, and so on, and tries to generate documentation. The second one is the unit test generator, which will go through the application and tries to find out which unit test should be which should be created and tries to generate them. And the last one is the security reviewer. Well, we all know if we try to create some new application, there always something that we miss, And this is a great example how we can ask the Copilot, how we can ask the AI to go through our application and find something that will be vulnerable. So all of these three tasks could be done in parallel. So documentation does not require unit test, the unit test does not require security review or documentation, and the security review could do the code review without documentation and generating. All of them will be based on the code bases that we have in the application. And the result is the completion that we will get from the Copilot, from the orchestrator. So the first step was launch all three agents concurrently. The second step would be for the orchestrator to wait until all the agents are complete, because the orchestrator needs to get some information, some context to generate the output somehow. And after all of the agents will be ready, the orchestrator will get all of the context, get all of the responses of all of the agents, and aggregate them in a single report. So we see it working. We see that currently two agents, well, now it's only the one, which is working. The two other were already ready. So the documentation generator was the first one, because you do not need to do a lot of thinking process. But the code review is the most heavy. And now we have the output of all three agents. And what the orchestrator does, he just aggregates the results of the code and tries to provide us some information. So we need to have some documents right now. Okay, we see that there were changed something. So we have a documents generated for our application in README. Let us see what we have in README. Okay, we have the overall README, how to start the project, or where to find other information. We have README MD file about the finance app. So there is more information. If I click, so, well, it's looking nicer right now. So this is what the document generator creates. And we have the results from the test generator. So we have here a file with a test, and there are some tests that will be created within the test generator. And what I'm waiting right now for is the results of the security reviewer.
Well, while we're waiting for this, because I keep having the same question when I see all those like multi-agents working together. So can you go to your agent file? Can you go to your orchestrator? I want to understand it correctly. How I can actually implement it. So basically what I need to do is just to create an agent file, like a typical MD file. And what toolsets do I need to use? Do I have to, so I know that I need to provide a tool agent, and that's basically the only thing that I need to do, right? And then I need to make sure that all my other agents has a semantic description that my orchestrator will be able to map them correctly and understand which agent should be called. Is that correct? Maybe you can explain us this part.
Yeah, of course. Well, again, you're correct. We have the front matter, this part of the agent, where we define the agent itself, and we're providing the permissions for the agent, what it allows to do. And one of the part is the agents. Right now, I just mentioned that this orchestrator allowed to run each sub-agent or every agent that is available in this project. And because I'm not providing the names here exactly, well, I'm providing them, but it's not. I'm not obligated to do so. The Copilot will go through its definition, through its instructions, and tries to understand which kind of agent he needs to pick up. And based on the semantic, he knows, okay, for document generator, I need something, so some agent that works with document generator. And just for example, I have here this document generator agent. which is also described as a custom agent, and these have its description. So basically what the Copilot does, he goes into instructions of the orchestrator, tries to understand semantically what kind of sub-agent he needs to pick up, then goes through the sub-agents or edge agents that it allows to go through. And because I just said asterisk, it allows to use all of them. And here he gets to the documentation agent, looks in his description, understand, okay, this is a one who will generate some documentation. So he will pick exactly this one. The problem would be if you have multiple agents which have the same semantic description. In that case, you need to be more specific what the orchestrator should pick up. Otherwise, it will take one of them and not necessarily the correct one. I hope this answered your question.
Yeah. I mean, we're getting also some questions in the chat, but we have to be very cautious about time. So we also got a question about token consumption, and I suggest, because we're gonna be in the end, of course, in the end of the session, we will have like a wrap-up section, and there after we will have a look at all of the patterns. We will say a couple of words from the token perspective. I mean, is it gonna be using more? If you're gonna save anything on this. So wait a little bit until then, so we don't interrupt the flow of the session. And I know that I can see that there is also another question about agents and skills and plugins. What's the difference between them and when to use what? I mean, this is a little bit out of scope of the session, because if we will start explaining, we will not manage to finish the webinar about the orchestration. But just to say it very, very shortly, agent basically as a persona role, you can tailor it to the specific flow and a skill. So you have to, if you use an agent, then you have the whole session in the same agent, and then you can switch between different agents. And skills, it's basically as you have in the real life. This is something that your agent learned to do, and then you can use multiple skills within the same session. So one agent can use multiple skills. And plugin, I mean, well, it's kind of quite like all the things, they're quite similar in the concept. The difference is just when you use it. I mean, if you really want to add something, especially about plugins, because I don't use them at all, this would be great.
I do not use the plugins either, but one thing that I would add to the skills, the specialty of the skills, that they will be picked up automatically based on the task. So you do not provide. So here we're just selecting the agent that will run our task, but by the skills, you just define the skill, and based on the task that will be asked, the Copilot will pick up these skills with additional knowledge base, with additional functionalities, and use this as the generation. So you can use the skill like for generating code. If you want to get over the time zones, you can just describe how to deal with the time zones, and even which parts of code should be returned when you use the skill. And when the agent pick up the skill, you get exactly what described in the skills. About the plugins, I cannot add really anything to you because I'm not using them either. I know they're existing, but again, it's enough with agents and skills, so I can use them, and it's okay.
Yeah, same for me. I actually even forgot about their existence until we got reminded. But I always thought about plugins as like a third-party things that you can basically just plug to your application. But in any case, I mean, agents, think of agent as a persona, and then think of skills as different things that this one particular persona can learn to do. It's very much the same as in real life. You can be an agent and you can have multiple skills. So can you show us how would this whole setup look like if I would want to run it sequentially but not in parallel? I mean, I can say a couple of words about the concept itself, and then you can switch to the demo as well.
I just want to get back to our concurrent, just wrap up what we have here. It's ready with its task. So we have here aggregated information, and we can then work on this aggregated information further. Okay, good. Let's now get back to our slides and proceed to the next pattern, the sequential concept. Well, if you want,
if you can,
yeah,
can you switch to the presentation? Yeah.
Oh, I switched to the presentation. Do you see my screen as a presentation right now?
I still can see your Visual Studio Code.
Okay, that's unfortunate. I will try to stop sharing and then share again. So maybe then you will see my presentation. Oh yeah,
now we can see. You see, it just always takes a second try. Let me say a couple of words about the concept of sequential orchestration. So as usually, I will explain the theory and then I assume how it works, and then you will verify if that's really true or not with an actual demo example. So when we're talking about sequential approach, we of course talking about a fixed pipeline. So it's very good when you have a certain workflow and you don't want to miss any tasks, any steps out of it. So each step will improve the results. So you basically have a dependency from one step to another, and then output flows stage by stage. So it's really good for tasks like content generation, data enrichment, when you have a strict ordering of your tasks, and then you have to review your workflow. For example, I think this is the demo. I sneak peeked at what Yuri was already showing, the demo that he has. And correct me if I'm wrong, but it's going to be a feature implementer. And I assume that this is exactly the best case for sequential approach, because instead of just focusing on writing the code, but we will also be focusing on first writing the code itself, then generating for it unit tests, and then writing the whole documentation of the whole feature, what was implemented, what test cases were covered, and everything that took part of it. And in this case, it has to happen sequentially because we cannot describe the feature without having it written. So that's exactly the schema that you see from the right side of the screen. When we first do a certain research or implementation, we create some draft or we add some unit tests. So like from one agent to another, we pass certain things, and then we finalize it. We have in our output as the final result. So with this one, Yuri, you have to prove me wrong or right now. So you have to show it if that's really how I describe it.
Yes, Nika, you already saw my my
I did.
demos.
I was looking what you were showing.
Yeah, sure. Yeah, I will turn back to my code. I will undo the changes that the Copilot done so far, so I can do it with a clean code. Again, we will work with this application, but yeah, the sequential, this is correct. Well, if you, for example, implement some feature, so what you do the first you implement the feature, the second you tries to generate unit tests, and maybe then do a security review, and then document the feature. So what does it mean? It means you are going to the Copilot and ask the Copilot first do this, then do this, then do this, and then that. And because we're all lazy, we do not want to spend a lot of time by switching the agent or writing a lot of prompts. What we actually do in that case, so we will create a new orchestrator. It's a feature implementer. Here's a lot of different things written down, but the main thing that you need to understand, we're generating an orchestrator or agent that will do its own thing. So the orchestrator is not only should orchestrate and tell the other agents what to do, it also can do its own work. So what we have here, the feature implementer will implement some feature that we're asking him to do. And then based on what he designed or what he implemented, he will start to run the sub-agents through. So we have here the first sub-agent that is unit test. Again, it will pick up by semantic matching. So if it will find the agent that can run unit tests, and this would be, I hope it would be, the unit test generator. And after unit test will be done, it will run some other agent, which is documentation agent, and I hope it will be documentation generator. As far as I do not have any other documentation generator agents there, and will provide me with a README file for documenting. One thing that you left out is that the specialty in this sequential calling of different sub-agents is that the context will be shared between the sub-agents. So basically in the concurrent, we have the context base from the whole project that will be pushed to all of the sub-agents, and they will work with the context and get the generate the output, which will be then aggregated by the Copilot. In this case, we have a different approach, a different workflow. So again, I forgot to start the feature implementer, so I will run because it takes also a little bit time to provide the output. So what we will ask here, we will ask the Copilot to implement a new feature that will find the most used category in the present and present it in the application. So I will start it. This is some kind of feature. In your case, it could be something completely else. But the main thing is here about the context that in this case, the feature implementer will try to implement the feature that I'm requesting the task. Then after the feature will be implemented, the context, so this implementation will be pushed to the next sub-agent. In that case, this will be a unit test. The unit test will not go through all over the project. It will know which unit test or which part of code it should go through and generate unit test for. And then after the unit test was generated, the results will be pushed forward to the next sub-agent. So the context will be shared sequentially from the first to the second and to the last agent. And so they're sharing their context, they're sharing the knowledge, what they are working with, and the documentation agent will then generate the documentation to the feature that was implemented. So we see a couple of steps already done there. Right now, I hope this is so the feature implementer create a plan for our new feature. It shows the steps to execute, and then it goes through the steps. And currently, we see that the sub-agent was called to generate some unit tests, and we see there is no documentation agent that's running parallel. So it waits until it's ready to do something. So we have some runs. I think I need to stop my application because it will not be able to run any tests. Okay, and it runs the tests in behind. So right now is the unit test working, and the documentation agent just waiting in the queue until it gets its own
But it's not.
task.
It's really nice that you can see that your sub agent is actually being triggered, because I remember it always confuses me when there are skills and sub agents and you don't see them in the chat, and then you're like hesitating if they were really called or not. But in this case, it's very, very clear. So when your skill is being called, it's also like calling the skill or executing the skill. And in this case, it's also sub agent, and then you see what's going on in there actually.
Yeah,
While we're waiting for the result,
this was the upgrade of the Copilot that now for the transparency, it's showing what it's actually do. For in early days, I would call so, we could just open the work, the task or the processes that it went through, and there we could see if the skills or agent was called. But right now it's really transparent, so we see what's happening. And right now is the documentation agent does his work.
Let me just say one thing, because I also keeping an eye on the chat meanwhile, and I see that some people asked about MCP server. I just want to make it clear that we are not using any MCP servers here. So the bare minimal setup for showcasing those patterns is the agent toolset, and then multiple agents with like specialized agents, and then your orchestrator that basically takes care of deciding how to delegate the task. And you just basically have to describe it in your orchestrator MD file, like how do you want the execution to happen, sequentially or in parallel, or if that's going to be a group chat, and then GitHub Copilot will do all the magic for you. But there is also a really cool question that I think a couple of days ago I asked you. We had the same conversation about the thinking process. Basically, how long you want each agent to be busy, or like how deep it should think about something. So I know that there is no default set, like there is no integrated or built-in capabilities of actually restricted or change the thinking process, but there is an effort process, right? There is an effort level which is like low, medium, and high, and it's like related to model that you can basically set how much one model should be thinking about certain task. But there is no strict like borders that you can set, but it's more like model related. It's called thinking effort, and you can also exercise a little bit with the language in the agent itself. So you can say, don't think too much at this task, respond immediately. If you don't know the question, then delegate it to the next question. Like you can play around with those things. But Yuri, you probably know more than I say.
This is correct what you're saying. I just want to add there is an extension for different models. So not all models supporting that, but there are models that are supporting set up of the context and of the thinking effort. So, for example, if I'm using, I will try one of the models.
Claude Opus
GPT-5
definitely
Mini
has it. Oh, yeah,
or
sure.
GPT-5 Mini. It has, for example, here the thinking effort. So you can choose between low, medium, and high. So based on what you're choosing, there will be spent more or less time for the thinking. And
can we configure this? Can we configure this within the agent itself? I think it should be possible, right?
Let's try it out. So we're just saying I want to use GPT-5 Mini, Copilot, and effort. Middle, no, default. I do not really know
we can try it out the way how to set it automatically, but we definitely able to control the effort level. It's just a question of if it can be done with the agent. I mean, it should be done. If you can change it from the UI, then it should be
several modern location. Well, I need to search for this option, how to implement that. Let's see what am I lagging or it's you're lagging? Okay, what I want to show here. So I have here the effort, and I also can set up the context for the model. So this is also the option that I can set up. So the result, we have some results from the agent, and what we have here implemented the code, what we have. So there are some features were added, and we also have some documentation to the feature. So here we see the feature was implemented, and here's the description of the feature. Okay, so can you hear me, or am I lagging? No? Okay, great.
No, it's probably just me. Yeah, you're good.
Okay. Great. So this is how you can run the sequential orchestration in your Copilot. So it's really convenient if you are lazy, which we are, and you do not want to spend a lot of time to just orchestrate and call the one agent after another, you can just describe the agent that will call sub-agent subsequently, and they will share the knowledge and implementation between them and get exactly to the perfect result that you would like to have. So, and
well, I hope I'm not going to be, I hope I'm not lagging too much right now, but there was also a question in the chat, just real quick, if we have to specify Copilot part when we provide in the model, and I mean, in the agent file itself.
What do you mean with this?
If you go to the agent file.
If I'm required
to
specify the Copilot model.
No, you say the model, and then you wrote GPT-5 point whatever, and then there was like in brackets, there was Copilot written.
Oh,
so it picks up the model from Copilot because yeah. So it's selected automatically, and probably you have to select it. You can also vary your different models, like from the local provider. So probably it's better it just points out from the source of the model. Yeah.
This Copilot thing is the configuration thing from the GitHub. So it's available for Copilot. That's why we're here standing the Copilot in brackets.
Let's move to the next one. And if I'm going to be glitching again, then Yuri, please, you have to keep an eye on this. I don't know why my connection is dropping. But yeah, we have to be a little quick now. So we have a handoff. So a concept of the handoff pattern is when the control has been passed by rule conditions. So as I was already mentioning, we basically have an if-else case. And only one agent is active at a time. So this is not a concurrent scenario. It's good for escalation chain. So basically, if something happened, then we go to this agent. It's nice for routing to specialists. Again, the same. So if we have the task or an issue that requires a dedicated attention from a specialized agent, that would be also very good for handoff.
Okay.
Our sequential approach. Yeah.
You were again lagging.
Yeah. Okay. Then you just have to take the demo part and then just show how it works.
Yeah. Simply saying the handoff orchestrator is something like, it's about when you start the agent to do its work, it just decides by its own which sub-agent is the most capable to acquire this, to accomplish this task, and will hand off. That's why it's name of handoff the task to the next agent. And next agent is working on that. And if we're ready, he asks the orchestrator, okay, who is next capable of, and then it will be shared further and further the whole implementation. And exactly, it works in sequential mode, so there are no concurrent implementation. And what I will try to do here, again, I will start a new session and will ask the router to accomplish some task. The task will be I want to implement also a new feature, which is monthly spending summary feature for the finance application. I will not go through the whole story here. What I would like to do is just run it and explain how it builds. So we have here the router, if I find him. So here's the router. And again, we have the name of the agent, we have description, what the agent exactly does, we have the handoff, and here we're describing your handoff orchestrator. Your responsibility is to determine which specialist agent is best suited to handle the current request and transfer ownership off to the task accordingly. So based on the executing, and right now we're seeing that this orchestrator decided that the feature that should be implemented is best suited for C# expert, which is logical. We have the C# application. The C# is most capable of to do so. So it hands off to C# expert. So here we have the different responsibilities description. We have a C# expert, which is good at implementation feature, refactor code, fix bugs, and so on. And there are also other agents that are best suited for example, for reviewing. So the reviewer agent that we also have in the list of the agents, this code review, it's most capable for review existing code, identify calls, smells, improve maintainability, and so on. So there is also security reviewer, unit test generator, as we already saw how it works. There is documentation generator. Again, we saw how it works. So we're just describing which agent are available and which what capabilities do they have and which parts and areas they're most suitable. And then the orchestrator will decide which part of the task will be handed off to the best suitable agent and call this agent. And here are the handoff rules. You can describe them, you can omit them, it's up to you, but with the description you will get more out of it. So we have the specialist, so we're describing each of the agent is their own specialist. And what should be done there when the request evolves, because the some parts of the code will be changed, something will be added, something will be removed, and the new part, the new code requires a different expertise. He needs to summarize the current state of the current code. He needs to transfer ownership to the most appropriate specialist. It should preserve relevant context, so it shouldn't get a whole context because it's just switching. It should need he should only take the relevant and continues where the previous agent stops and hands off its the next task. And what we see here, the first was the C# expert. And the next one was the code reviewer. And the reason because why it hands off to the code reviewer, even this we get here, feature implementation is complete, now transferring to code reviewer for code quality assessment. So it takes another agent to check the work from the previous agent. So it's like self-controlling. And then after code reviewer, we have a security reviewer because the code quality was completed. Now it's to check if the code secure enough. And so on, it works further and further until we get the result implemented feature. So this kind of work is great when you just let the Copilot decide which of the agent is best capable of for the current tasks. Okay, it's working. You see the agents take a little bit time to complete its task. It needs some time, so I think we could switch to the next pattern. So let's get straight to the group chat concept. And this is one of the funniest of them.
I mean, it's you can hear me. Can you hear me, right?
Yeah.
Yeah, it's basically reminds me when I'm really sad and I just start having conversation with myself. This is somehow the same thing. Like it's basically if there's no agent exist, but you try to, like you say, that to delegate it to a certain agent, I feel like there's gonna be like just a head changing, you know, like now I'm this agent and now I'm this agent. I mean, it's quite funny approach because it's you have a shared conversation and you can observe the whole thing that's happening. So the manager or like the main orchestrator chooses who's going to contribute to a conversation next. And what we're going to see now, this is like really funny. It's like C# agent responds to like code reviewer responds to C# agent, and then like quality assurance responds to both of them, and then PM responds to all of them. So it's like literally going to be like a mic dropping conversation every time. And there is going to be a couple of iterations. So there is going to be no fixed order, but you can see from how from some sort of a chaos, they will be able to reach certain conclusion for like a complex problems or certain architectural reviews, and basically reach a consensus, have a certain decision in place. So I mean, it is funny to talk about it, but in essence, it's a very powerful tool that can give you really strong capabilities of assessing complex and complex tasks like architectural reviews and decisions and code reviews in general. So we can have a look at how managers are going to be using different contributors and how they're going to iterate on in the same conversation, trying to reach an agreement. And from there, I will just let Yuri to show this. Like we have somewhat, just for your information, we have somewhat around 10 minutes. So try to make it in 5 so we are able to wrap up the session.
Great. I will start the conversation, but I will show the previous run so you get an idea how it works if we're not able to see the whole result. So what we have here, we have an agent orchestrator, which is the console. Well, we have this the whole console of different agents here, and there will be agents taking part: the product owner, C# expert, security reviewer, code reviewer, documentation generator. So they will communicate with each other based on different rules. And what I will do here, I will take this and send a request. So what I want to have, and I said, well, Copilot agents, I want to design a monthly spending insights feature that categorize transactions and show personalized recommendations. So let's discuss it. And what here actually happens, again, we have the orchestrator, and what the orchestrator does, he knows which agents will take a part, and then it's just not like a sequential, handoff, and concurrent orchestration. They will not work concurrently. The first thing that it will do, it will summarize the information that should be provisioned into the agents, and then it will start rounds of the discussion. We actually make it for 3 rounds. Yeah, we just make a shortcut for 3 rounds, because otherwise they could talk indefinitely, or until the end of the university. The first round will be initial thoughts to the feature for each of the agents, and then after they provided these their thoughts, they will look at the responses of each agent, and then each agent will respond to other agents based on his own thoughts. So it's running, but I would like to show you how it worked previously. So we have here the discussion. It's basically the same request, just run earlier. And here's the first round, initial position. So each of the agent just tells its points of view. So what should be implemented? The product owner has its point of view. The C# provides already some code. The security review says what needs to be aware when we implement this feature. The code reviewer also said how should the code be implemented based on the existing code. Document generator also give his note that it would be great if we have names for the classes that are speaking for themselves and so on. So here we have the initial thoughts of each of agents, and then the discussion starts. And the part of the orchestrator, he provides like a mic to each of the agent and let them tell something. And we see that the, for example, C# expert responds something to the code reviewer, and he said, well, okay, I agree on extending service, finance services, and I initially considered a separate service to keep file size manageable, but the existing financial service is only 17 lines, so it'd be okay, it'd be fine when there are some more lines. The code reviewer responds to the C# expert to that. Well, the two-query approach for prior month data is correct. However, be careful with the group by. So the code that you provided, you need to be aware of the group by. And then he provides what he would like to see in the code. And there come the security review also speaks to the C# expert. Well, pay attention. The guard clause on year and month should be at the top of the function. So you need to have some guardrails there. And the product owner saw the whole conversation, says, okay, code reviewer, agree to that logic that you provided. Want to confirm that this is a radar page and so on. So this is a very funny conversation, and it seems like to be the conversation between different people that had different roles, and they have their own opinions, and they provide their opinions in the same way the Copilot and AI mimicking this interaction. And at the end, what we have here in the third round, they need to find a compromise. And here we have some consensus, what should be done. And the orchestrator summarizes this and provides us the final recommendation how to work with the provided solution. And here are even some key trade-offs that should be made while this conversation, while the implementation. So this is why it's so funny, because they're communicating with each other in this manner. And really, as I saw it at first time, I was laughing out loud, nearly fall out of the chair.
Yeah, I remember that. Well, we have just 3 minutes left, so let's try to wrap up this session. I mean, we're getting quite a lot of questions in the chat, and to be honest, like I feel like it could be as well like 2 or 3 hours session. Long story short, patterns are composable, so you don't have to limit yourself to one pattern or another. You can as well have like a nice composable system for multiple patterns. But of course, we also touched the topic of UBB. I mean, you can go to the next slide because we can just wrap up the session itself and then maybe take like 1 minute for the UBB. So there are some things that can go wrong. And of course, some of the things we already mentioned in the chat, like how do I take care that I'm not being stuck in the loop? How do I take care of about my tokens? How do I how to basically mitigate those risks, like cost spikes, having no audit information and having lost context and such. So you can see what pattern is at risk in this case, and then what are the mitigation steps. I will answer a few things that were in the chat, like for example, how to have certain insights on your sub agents and stuff. I mean, in some cases, you will have to. There's no built-in function. You will have to use things like OpenTelemetry, and your sub agents, especially when you're using Copilot CLI, they produce traceable items. Then you can inspect afterwards. But of course, you have to build on top of it. There is no out-of-the-box solution yet. And then if you're talking about design principles for production, you should go back to the presentation.
Yeah, I wanted to show this counting that the CLI also provides.
Yeah, I mean, it's counting the session, but it doesn't really count like a separate sub agents. So when we're talking about principles, it's of course you have to prefer predictable flow, that the one that you already know, the one that will not give you any surprises. I mean, parallel execution is great, but might be a little bit tricky to work with it. Always keep human in the loop. Fail gracefully, so every agent needs to have a safe fallback path. Observe everything and try to also build some observability and traceability on top of it. And of course, version your agents. This is very important, especially also when the models are being released. Make sure that you make some testing, make sure that you also compare those models. And there are some key takeaways, but I think we can touch real quick about the models, about the UBB change and everything. So I saw in the chat there was a comment like if it's even like makes sense to use GitHub Copilot because of this new UBB change. I mean, Yuri, you can. I know that you know a lot about this. You can give your opinion. In my opinion, they made this switch, which is not very comfortable at when this change happened. But in general, it's basically the same as other providers have. So it's a usage-based, it's whatever you use, you pay for it. And I think that it's not that big of a problem because we all have to learn how to use it effectively, how to take care of our context window. And so it's just a matter of educating ourselves a little bit. But of course, when the change happened and how it was communicated is not the most comfortable thing. But maybe Yuri has other opinion, and now he will tell you all to switch to a different provider. So let's see.
I will not advise you to switch to another provider, but be honest. We have a lot of time that the Copilot and Microsoft provided us this such a great tool nearly for free. We had a premium request, and nobody cares about what the task was. So we could use the GitHub Copilot for a very simple task, and there is a lot of computing behind the scenes. So it was a logical way, or the logical conclusion, that sometime the GitHub will switch to this usage billing, and we see that the other provider already do this. Yes, this is not a comfortable thing, especially when we all used to use those premium requests. But yeah, this is life. Everything will be not cheaper, and we just need to learn how to use them.
Real quick about orchestration. When we talk about orchestration, how does it influence our token consumption? I mean, from my understanding, from my when you send the prompt and then you have a thinking process, it's gonna be basically the same as when LLM sends the prompt. The only difference that when one agent sends a prompt to another agent, the only difference that you will have is basically in this communication between agents. So when one agent communicates to another agent, this is going to be like your token differences. This is in my understanding, but we had this conversation going on for already a couple of weeks, I would say. Yuri, what do you say?
Definitely the agents, they generated more output or more context or more complicated prompts than the humans generating. So this is all of all prompts, there are input prompts and input tokens. So yeah, of course, because the agent generates them, you will get more tokens there, more token usage there than when you would write this message. Mm-hmm. But you have the advantage that the Copilot will think of different things and provide more and specific context for the next agent. So here is a trade-off, what you would do by yourself, and if maybe you need to spend more requests because of the uncertain prompts, and the agent will do the same in more compact way. So it just needs only one request for the agent, and for you need a couple of requests. This is a trade-off, I think.
Yeah, I mean, they also, from the other perspective, when we used to send a request in the past, it was like whatever we say, it doesn't matter how long or short it was one premium request if you were using the premium model. I mean, plus multiplier, of course, but it was like one premium request that has multiplier 1. Now we pay for what we send. So if it's a very, very short sentence that you say like, okay, fix this problem, then you basically spend no tokens on it, right? And before, it didn't really matter. If you say something very short, it's going to be one request unit for this. So, I mean, it's how we see it. There are different perspectives. It's a very uncomfortable change. But I mean, industry is changing, and integration of AI in our life was also very sudden. So now we have to give back and actually learn a little bit of how to use it. Are we planning to share the steps to configure the agents? I mean, I asked the question if you're going to share slides and then examples. I mean, we see what we can share, what are we supposed to share. We're definitely going to share slides. And then, well, you can follow up with what content will be shared afterwards.
Yeah, and do not forget do not forget to register on the AI SkillFest, and there you will also find a lot of different sessions that you can attend, and maybe there will be some interesting facts.
I also want that badge. This badge. It looks very colorful. I like those colors. I mean, we are right on time. It's 1 hour and 5 minutes, so we took a little bit time extra, but thanks everyone for attending and great questions. I mean, honestly, I would love to have like a whole more hour of the discussion. But we have to stop at this point. Thank you very much, everyone, for attending. Please join other sessions as well. And thank you, Yuri, for all those awesome examples. This was a pleasure presenting with you.
And thank you for clarification and describing what the patterns are. It was also very informative. And I think everyone joined our session.
Thank you very much. And well, enjoy the rest of the day and enjoy your week.
Yeah, thank you and bye. Have a nice day.
Thank you. Bye-bye.